under the heading of Know These Concepts. The first set of problems are based on a very simple idea. If I have a line L1 equal to 0, and I have, where L1 is a linear expression in x and y, and I have another line L2 equal to 0, then any line L of the form L1 plus lambda L2 equal to 0 will pass through the intersection of L1 equal to 0 and L2 equal to 0. Was there an iota of doubt in this? No. If I subscribe to different values for lambda, then I get different lines. But then this family of lines will always pass through the intersection of L1 equal to 0 and L2 equal to 0. Yes or no? Right? And all of you understand this, isn't it? Now let's quickly get past some of these situations represented in the small little sheet. Now, so the first one is about three numbers A, B, C that are in AP, arithmetic progression. However, these are not fixed numbers. They are not referred to as fixed numbers. They are parameters. Any set of three numbers you could choose for the sake of the problem, as long as they are in arithmetic progression. You could choose 1, 2, 3. You could choose 2, 4, 6. Any set of three numbers A, B, C could be chosen as long as they are in arithmetic progression. How many such set of numbers can you produce? Infinite, obviously, right? But then, it's not a wild choice of three numbers. It's a conditional choice of three numbers. The condition is that the three numbers must be in arithmetic progression, right? Now, every time you choose three numbers in arithmetic progression, you generate a straight line, say, out of it. AX plus BY plus C equal to 0 is a straight line which could be generated out of every such choice of three numbers A, B, C in arithmetic progression, right? You could have had a line like 1 into x plus 2 into y plus c equal to 0, or 2 into x plus 4 into y plus 6 equal to 0, and so on and so forth, right? How many lines could be generated? Infinite lines, right? Now, what we seek to prove here is that the entire set of lines generated thus have to be essentially concurrent lines. The entire set of lines generated thus have to be concurrent lines, and ABC are not fixed numbers, they are parameters, right? Now let me first give you a complicated way of doing this, and then I'll give you a simple way of doing this. All right? The complicated way is, of course, if ABC are in AP, 2B must be A plus C. Yes or no? Right? So what I do is, to reduce the number of parameters here, I eliminate any one that I want. Say, let me eliminate B from this, so that I have an equation in the form of two entities A and C rather than A, B and C, right? So I say AX plus B I write as A plus C by 2 into Y plus C equal to 0. Right? I now collect terms that contain A and terms that contain C. So when I do that, I end up getting A into x plus y by 2 plus C into 1 plus y by 2 equal to 0. Yes or no? Right? A into x plus y by 2, C into 1 plus y by 2. Now, do you realize that x plus y by 2 equal to 0 is a straight line. This is a linear expression. When equated to 0, it's going to give me a straight line. L2, which is 1 plus y by 2 equal to 0 is also a straight line, y equal to minus 2. Yes or no? Do you realize this then is a linear combination of two lines? This is lambda 1. It's a parameter. A and C are parameters. Lambda 1, L1 plus lambda 2, L2 equal to 0. Where L1 and L2 are two linear expressions in x and y. This line, therefore, no matter what choice of lambda 1 and lambda 2 I make, no matter how I select my A and C, this family of lines, this is now a family of lines because A and C are not fixed points. They are family of lines. This family of lines will always pass through the intersection of the two fixed lines L1 equal to 0 and L2 equal to 0. This bunch of lines will always pass through the intersection of L1 equal to 0 and L2 equal to 0. That would be the point of concurrency of all these lines. And intersection of these two lines, this gives me y equal to minus 2. The point of intersection must then have y equal to minus 2. And x then would be 1 minus y by 2. So all these lines must necessarily pass through 1 comma minus 2. They are a bunch of concurrent lines. They are a bunch of concurrent lines. Yes or no? Right? And what I did was rubbish. Okay. Let's do it in a more simplistic fashion. Clear? Can I wipe this off? Yeah, please. Clear? Now, I didn't have to do whatever I did here. I wasted your time, wasted my time, but then there was a purpose so that you got an idea of how to use that linear combination concept, but it's not like just because you know something you have to necessarily use that, even if there are easier ways of doing it, right? Don't do all that I did there. For the sake of problems of this kind and this breed, look at this. I simply write this as A plus minus 2B plus C equal to 0. Yes or no? Isn't it? This is like A into 1 plus B into minus 2 plus C equal to 0. Yes or no? Hey, done. Therefore, this line will always be satisfied by x equal to 1 and y equal to minus 2. Yes or no? Minus 2b. A plus C minus 2b equal to 0. To be or not to be? And then to see or not to see? Right? So, if this condition is always satisfied, that means this line will always be satisfied, this equation will always be satisfied by x equal to 1 and y equal to minus 2. Therefore, this family of lines will always pass through the point 1 comma minus 2. Yes or no? Right? Very good. Doesn't mean, the point that I'm not trying to drive home is that you won't have to use that linear combination concept anywhere, but then, more often than not, things might reduce to such a pass and you will not have to, get into complications. Okay? Shall we move to the next one then? The second one, if A, B, C are in HP, we want to show, and they are parameters. There would be infinite set of triplets ABC in harmonic progression, right? So they're not fixed numbers, they are variables, they are parameters. And every time you select three numbers ABC in harmonic progression, you construct a line out of those three numbers. The line is BC into X plus CA into Y plus AB equal to 0. With every set of three numbers in HP, you can construct a line of this kind. Now, infinity of such lines, what we want to show is these are a bunch of concurrent lines. They will necessarily pass through a fixed point, right? Okay. ABCR in HP means B must be the harmonic mean of A and C. B must be 2AC by A plus C. Yes or no? Which means BC minus 2AC plus AB must be 0. Yes or no? Which is like BC into 1 plus CA into minus 2 plus AB equal to 0. That means this equation will always be satisfied by x equal to 1 and y equal to minus 2. So this again represents a bunch of concurrent lines, and the point of concurrency would be 1 comma minus 2. 1 comma minus 2 would be the point of concurrency. Yes or no? Right? There was no necessity to convert it into a linear combination, although that could have been done. It's all right to be able to do that as beginners, but then while you mature in the subject, you might be able to dispense away the same on a large number of occasions. Right? Can I wipe this off? Are you all okay with this? Again, no, it will not happen. Unfortunately, you will not get a linear combination out of it. That's a problem. Again, ABC are parameters such that choice of ABC commensurate with this equation. A square plus 9B squared is 6AB plus 4C squared. So, here I have the option of selecting ABC, but not wildly. I can select ABC, only those ABCs would be considered legal if they satisfy this condition. But once again, you know, there would be infinite sets of ABCs that would satisfy this condition. And with each legal ABC, I construct a line. The line that I construct is AX plus BY plus C equal to 0. So I have a family of lines at my disposal. I want to be able to show that the family of lines thus produced would be a bunch of concurrent lines. This is what we want to establish, right? Again, and in the sense, concurrent in the sense, either they will pass, this problem says either they will pass through one point or some other point. This is what we want to establish, you know. Many lines are produced out of this. Now I'll be able to show that there are 2 points. All these lines will pass through one or the other of the 2 points. There are 2 fixed points. The assertion is that there are 2 fixed points, and all such lines will pass through one or the other of those 2 fixed points. Question is, what are those 2 fixed points such that these lines will pass through one or the other of those 2 fixed points? Now again, it takes no rocket science to see that if I combine this and this and this and bring them on the left hand side, I end up getting A minus 3B whole square when I transpose it on the left hand side, and that's equal to 4C squared. Right? Or A minus 3B equals plus minus 2c, right? Or a by 2 minus 3 into b by 2 is plus minus c. Right? Now, let me look at both cases, the plus sign as well as the minus sign. When I look at the plus sign, then a by 2 minus 3b by 2 minus c is 0. Right? Which on I want to make this plus c so that I can compare with this. So I multiply throughout with a minus so that I could eventually compare with this. This also becomes plus c. Right? I multiply with a minus sign. So minus a by 2 plus 3b by 2 plus c is 0. Right? Yes or no? Now on comparison, this is like a into minus half plus b into 3 by 2 plus c is 0. Right? And then out of sheer comparison, I end up getting that this line will pass through minus half comma 3 by 2. That's one of the possibilities. Either it will pass through minus half comma 3 by 2 on comparison, yes or no, right? Or that's one of the possibilities, or the other possibility is if I took the minus sign here, if I took the minus sign, then a by 2 minus 3b by 2 plus c 0. If I took the minus sign here and transposed, this would give me a into half plus b into minus 3 by 2 plus c is 0. Right? That means this line then out of comparison will pass through ax plus by plus c, means x is half and b is minus 3 by 2. That means x is half and minus 3 by 2 will satisfy that. Half comma minus 3 by 2. That means there are 2 points, P and Q. And all such lines produced will either pass through Q or will pass through P. One of these 2 fixed points. Yes or no? Clear now? No issues? Number 4. There is a variable line with variable x and y intercept. What we have is a variable line like this, where the x-intercept a0 varies, the y-intercept b0b also varies. A and b are parameters. Every time you select a and b, you select them in a manner that sum of their reciprocals is a constant. Sum of their reciprocals is a constant, right? And that constant would be given to you. Okay, say 1 by a and b are allowed to vary, but as long as the sum of their reciprocals is, say, a constant 1 by k. Say a constant 1 by k. Right? And then I want to show that all the lines produced thus with parameters a and b defining this condition at each instant, then the set of lines thus produced would be concurrent lines. Again, no rocket science here. At any given instant, if this is the state of the line, then the equation of the line in terms of the intercept is going to be x by a plus y by b equal to 1. Yes or no? Now look at this, multiply throughout by k. K by a plus k by b equal to 1. That means k comma k will satisfy this equation. That means k comma k will satisfy this equation. Yes or no? Right? K comma k will satisfy this equation. Therefore, this line, even though a variable line, will always pass through a fixed point k comma k, no matter what choice of a and b I make, as long as sum of the reciprocals of a and b is 1 by a constant. Yes or no? K comma k is the point. Is that okay?
Sir, if you have taken the constant 1
1 by? No. Then this would have become 1 by k and 1 by k. Then the point of concurrency would be 1 by k comma 1 by k. No, certainly not. That's perfect. That's absolutely perfect. Now we have a and b as parameters. X into a plus 2b plus y into a plus 3b is a plus b. We need to show that family of such lines will be concurrent. Now this is fairly simple. In this case, you have no option but to go by that. You combine terms containing a, so x plus y minus 1. Combine terms that contain b, 2x plus 3y minus 1 equal to 0. This is very clearly a linear combination of two fixed lines. One line is x plus y minus 1 equal to 0. The other line is 2x plus 3y minus 1 equal to 0. And obviously, you can find the point of intersection of these two fixed lines, which will be a fixed point h comma k when you solve these two equations. Yes or no? Right?